Hey guys, just recording another video on the idea of constructing constraints, specifically constructing constraints in a table. So far in your questions and exercises from the book, you've been drawing simplexes from constraints that you're already provided as line equations. But in worded problems, it's more complex, and the constraints must be interpreted from the question information. You're not just going to be given the line equations to draw straight away. Sometimes it can be really useful to tabulate the given information in an organized fashion, as this makes it easier to devise the constraints because you're going to be able to see the resources in the question that will have constraints applied to them really clearly, and you'll be able to see how the variables will interact with those constraints. There is not a set of steps for doing this for all the questions you're going to face. I'm just going to show you an example here, then you're going to practice with multiple exercises on the timeline. Okay? Why is that a comma? That must be a full stop. So, for example, we have a cabinet maker producing 2-drawer and 5-drawer filing cabinets. The cabinet maker has 34 drawers, 8 locks, and 42 square meters of sheet metal available to use in his workshop. Each 2-drawer cabinet requires 1 lock, 2 square meters of sheet metal. Each 5-drawer cabinet requires 1 lock and 4 square meters of sheet metal. If I say X is the number of 2-drawer cabinets made, Y is the number of 5-drawer cabinets made, construct a table organizing the relevant information, then use it to produce a set of constraints defining the scenario. So, this is an example of looking at a bunch of worded information, breaking it down into a table, and then when it's in the table, you'll see why that's useful because it makes it easy to see the constraints visually. Okay, so my suggestion is that you have a table. In the first row is the resources represented. In the question, then you have the X and the Y, and then you have the limit of the resource. Draw the line there. I'll just make it 5. Now, what are the resources? They're usually defined by the thing that it says I have available. I've got drawers, I've got locks, and I've got square meters of sheet metal. So my first one will be drawers. My next one will be locks. I'm just going to do it in the order of the question. It really doesn't matter. And then the last resource I have is metal. I think we'll just leave it. We don't know. No. For now, we're just going to draw the table like this because I know there's only 2 variables, which is the number of the different kinds of drawer. Finish the table. Okay, what does a 2-drawer cabinet use in terms of drawers? It uses 2 drawers. What does a 5-drawer cabinet use in terms of drawers? 5. What's the limit? I have 34. Locks. What does a 2-drawer cabinet use? It uses 1 lock. What does a 5-drawer cabinet use? It also uses 1 lock. What is the limit on locks? I have 8 of them available. Metal. A 2-drawer cabinet uses 2 square meters of sheet metal. A 5-drawer cabinet uses 4 square meters of sheet metal. And the limit I have on there is 42. That's as far as I can see is the limit of the resources. Why is this useful? Well, I have a limit of those things, so I'm going to use up to and including 34 draws. I'm going to use up to and including 8 locks. I'm going to use up to and including 42 square meters of sheet metal. So these are all going to be less than or equal to, less than or equal to, less than or equal to. And hopefully you see with this table, it makes the constraints very easy to construct. Why? Because you just look down. You look down the table. You look down the columns. Down, down. So my drawers constraint. Drawers will be 2x plus 5y is less than or equal to 34. Locks will be 1x plus 1y less than or equal to 8. Metal will be 2x plus 4y is less than or equal to 42. Those are my constraints. This doesn't ask me to draw it, but we might as well draw it. Let me copy and paste this onto the next page. Let's do this live. I haven't been asked to draw it, but you're going to be doing stuff like this in the question, so I might as well show you. I haven't practiced this. I don't even know if it's going to... It looks like there's going to be fractions, actually, but tough bickies. We'll draw as best we can. Yeah, definitely going to be fractions. How will I draw the drawers? Let's do the maths here. 2x plus 5y equals 34. X is going to be 34 divided by 2. 17. Y is going to be 34 divided by 5. I got adds on my calculator. Are you serious? 34 divided by 5. 6.8. Locks. 1x plus 1y is equal to 8. That's easy. X is equal to 8. Y is equal to 8. So no fractions there. Metal. 2x plus 4y equals 42. X is going to be 42 divided by 2, which is 21. Y is going to be fractional, I believe. 42 divided by 4. 10.5. Not a bad fraction, but still a fraction. So let's try to draw 17. 2, 4, 6, 8, 10, 12, 14, 16, 17 is there. .8. Are you serious? 1, 2, 3, 4, 5, 6. 6.8 is just slightly above there. Let's zoom in. Let me count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6. Sort of up near 7. It wants to go to the grid line. That's it. Let's try that. So what was that line? 2x plus 5y is equal to 34 that I just drew. At least the next one's easier. 2, 4, 6, 8. 8, 8. 4, 5, 6. 8 and 8. This will be on grid lines. So that is x plus y equals 8. 2x plus 4y is 42. X is 21. This was 17, 18, 19, 20, 21. Y is 10.5. That was 8, 9, 10, 11, 10 and a half. So that one is 2x plus 4y equals 42. So there's no other constraints there. So if I was drawing this, I can use less than or equal to 34 draws, less than or equal to 8 locks, less than or equal to 42 square meters of sheet metal. Less than or equal to means down and to the left, so I'm coloring down there, I'm coloring down there, and I'm coloring down below this. The only region that follows all those things at the same time is this one here. I do not color this little triangle here because even though it's below that line, I have to be below this line at the same time. I need to be below that line too. This line doesn't come into it. What is that suggesting? There's too much sheet metal, okay? Sheet metal doesn't come into limiting the solutions because there's so much of it and the drawers don't use that much constructing, okay? I'm not finished yet. If I was answering this question, I would need to label the vertices. So you've got 2, 1, 2, 3, 4, 5, 6, 2, 6. You have that point along the axis, that is 0, what was it? 6.8. You could make 0 and 0. And you could make 8 and 0. That is drawing the simplex for this problem. He didn't ask for that. Really, this is what you're supposed to be able to do from these exercises, but I figured I might as well give you more practice or show you more practice of what you're actually doing for this assessment task, all right? So hopefully that video helps you out in constructing constraints from worded problems, first into a table, then into constraints, and then a little advancement there showing you how you make those constraints into a simplex which you've seen before. All right, hopefully that helps you out, and I'll see you in the next video.